rotate about its center line, plus or minus 175 degrees. It also can be pivoted, obviously, between vertical and horizontal, which is basically the 0-degree position in which it is positioned for launch and landing, up to 90 degrees for the telescope berthing. There are 3 berthing latches on the berthing and positioning system itself, and these berthing latches are remotely operated. It also includes a blind mate umbilical connector, all designed to mate the hardware on the Hubble Space Telescope. In addition to being used for all of the previous Hubble servicing missions, the Flight Support System's original use was for repair of a satellite via extravehicular activity by a space shuttle crew. The Solar Maximum mission, or the Solar Max satellite, was repaired in the payload bay on STS125 back in April of 1984 using this flight support system, obviously specifically for that particular repair. The FSS after that was modified slightly to be used for servicing of the Hubble Space Telescope, and is now being positioned in the 90-degree point for servicing of the Hubble Space Telescope one last time. The 5th servicing mission obviously underway, with a rendezvous with the telescope scheduled for Wednesday morning, with the grapple targeted for just before noon Central Time. The Space Shuttle's robotic arm now in the process of unberthing the orbiter boom sensor system. It will be used quite extensively throughout the day today, with an inspection of the entire thermal protection system of the Space Shuttle Atlantis, including the wing leading edge panels, the nose cap, and also the tiles, the thermal protection system tiles underneath the orbiter, the belly of the orbiter. The sequence will include looking at the starboard reinforced carbon-carbon panels first, followed by looking at the tiles on the starboard or right side of the orbiter underneath. Then a conclusion of the starboard wing survey, followed by a maneuver over to the nose of the orbiter to inspect the nose cap, which also is made up of reinforced carbon-carbon. Crew will take a break for lunch and then switch over to the port wing and the port belly, or the left side of the orbiter, including the wing leading edge panels and also the tiles underneath the left side of the orbiter.
And Houston, Atlantis, we're recording.
And Houston copies, Ray J.
Yeah, the recorders are on, as we heard from the crew, as Megan MacArthur begins the process of maneuvering out to the right wing of the orbiter. All of the video from the orbiter boom sensor system sensor package will be recorded in the event that in the periodic times when the KU band antenna is not able to see the tracking satellite, to provide television coverage of the checkout. Atlantis is just about to pass high above Sri Lanka as it begins a southeasterly swing across the Indian Ocean, trailing the Hubble Space Telescope by about 8,000 miles. The scan of the right wing leading edge reinforced carbon-carbon panels is continuing. There are 7 different zones that that break down the panels. These affectionately are known as the Curry zones for the engineer Don Curry, who did an extensive amount of work after the Columbia accident to help understand the ability of the panels to withstand any damage. The scans that are being done provide near real-time information to the imagery analysis team that is stationed in the mission evaluation room here in Mission Control. They look at these images quite extensively and match those to pre-flight imagery before the vehicle launched to discern whether there was any damage incurred during the launch of Atlantis and the climb to orbit. A very similar scan will be done late in the mission to ensure that the panels had no damage from any micrometeoroid debris impacts during the mission. From the elbow camera on the shuttle's robotic arm, looking down across the tail of Atlantis as it has just crossed the equator to begin the 15th orbit of its mission, tracking northeasterly, just about to swing across Central America, just to the southeast of Acapulco, and then track across the Yucatan Peninsula and central Cuba before moving across the Western Caribbean and then out across the Atlantic Ocean. Atlantis is just a little bit more than 8,000 miles behind the Hubble Space Telescope, which currently is high above the Indian Ocean. The current altitude of Hubble is 350 miles. Atlantis's current altitude is 180 miles. The lower orbit of Atlantis, allowing the vehicle to catch up with the telescope over a period of the next day or so, with rendezvous and grapple scheduled just before noon Wednesday.